I'll wait till you get here.
Okay, logging in. Okay, I'm here.
Okay. You see that exponent?
Yes.
That is not a whole number. It's a fractional exponent. Okay?
So that wouldn't be considered a polynomial.
Right. But if I have I think that's what that says. Yeah. So I'm looking at 16. So both exponents that I wrote there are whole numbers, right?
Yes.
So I'm going to look to the biggest whole number exponent to determine the degree. So that would be this number.
5. Oh, no. Okay.
The
You're looking
exponent.
at the exponents.
You're looking at the
Okay.
exponent. So this is the fourth degree.
Is that to determine the endpoint?
That's to determine, because it says determine whether the function is a polynomial, and for those that are, state, I thought I read that. For those that are, state the degree. Do you see that part? For the directions?
Mm-hmm.
And it says those that are not, tell me why. And then write each polynomial in standard form, then identify the leading term and the constant term.
Okay.
So this would be the leading term because it has the highest degree. So if you're writing this in standard form, you would write this 4x to the fourth plus 5x squared. That's the proper way of writing it. You always write it in descending order in terms of the exponents.
Yeah, kind of like quadratic equation, right?
Right. Exactly like quadratic equation. Now, the constant term, there isn't one, right? Because you don't see a number that's by itself without a letter. So the
Yes.
constant term for this would be 0.
Okay.
Let me give you another example. I'm going to write 17. So this is g of x is equal to 1 over 1x squared. And then it's 2 at the bottom there. Okay, so this is a polynomial, even though it has a fraction, because the exponent is a whole number. You see that?
Yes.
So if I'm going to write it in standard form, so this would be to the second degree, because that's 2. And then if I'm going to write it in standard form, it would be, I'm going to divide 2 into both of these terms. So this would be 1/2 x squared, and that's negative, plus 1/2. Do you see how I got that?
So you'll divide 2 into both of these terms, the 1/2 and the x over 2, right?
Right. 1/2 and x over 2 are the same thing, right? Because this is at the bottom and that's at the top. That's a top number, that's a bottom number.
Okay.
Do you understand that or
Yeah.
not?
Yeah, I see what you mean. Yeah, it's just x over 2, but you just put the -1 there.
Right. Because the negative stays with the x squared, so I have to make it stay with the x squared here.
Okay. Gotcha.
Okay. So that's to the second degree, and now I have a constant term. So the constant term is 1/2. You see how that 1/2 has no letter with it?
Yes. So that's why it's constant.
That's why it's constant, because it doesn't have a variable with it.
Okay.
So
what is the standard form of a polynomial? Because it has the a and the m and the
okay,
n.
okay, okay. All right, let me do it this way because this is probably how it's described. So it's are they doing a1 and then x to the n plus a2 x to the n minus 1 plus dot 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 dot. Is that how they have it set up in your textbook?
They don't put they don't put the one there, the a to the one. They just put a n x n. Maybe I'll take a picture.
Okay, hold on. I just need to know the format. I can tell you how they did it.
Oh, a
Plus
n
a
x
n
n.
minus 1 x minus 1 plus
Yeah, that's how they did it.
a
Yeah,
n minus 2 x minus 2
yeah.
n minus 2 like that.
Plus
So
a n minus one.
this is all they're saying. This is all they're saying. If let's say my n is equal to 5, right? So they're saying that the first term has a degree of 5. So this would be a to the 5, and this is x to the 5th. And then the next term would be a to the 4, because I'm just going to subtract 1 from it. That's what this number is right here. I'm just subtracting 1 from it each time. So this would be x to the 4. And then this would be a to the 3, x to the 3. And then you count it all the way down until you get to a to the 0, and this is x to the 0. What is anything with a to the 0 exponent?
I think it's one.
It's 1. So let me show you how this relates to like real numbers. So if I did 7x to the 5th plus 4x to the 4th minus 6x to the 3rd minus 17x squared plus x minus 15.
Mm-hmm.
Then this is just saying that those two numbers are related to one another, because this is the 5th term. So that means that a to the 5 would be equal to 7, because it's just telling you the coefficient of that term. That's all it's telling you. So if this is the 4th term, then what is a to the 4 equal to? What number?
A to the 4 would be 4, right?
Right. What would a to the 3 be equal to?
A to the 3 would be 3.
No.
Oh.
What's a to the 3 equal to?
Oh, you're not asking what the degree is. You're asking about
I'm asking about the coefficient in front. Those
negative
a's are just
6.
saying the numbers in front of the variables.
Okay.
So what would a to the 3 be equal to?
Negative 6.
What would a to the 2 be equal to?
Negative 17.
What would a to the 1 be equal to?
1.
Right. What would a to the 0 be equal to?
It looks like it would be 0 or 1.
No. This part is 1. So it's like I'm taking 15 times 1. So what would a to the 0 be equal to?
Negative 15.
Do you see it now?
Mm-hmm.
So what degree is this polynomial that I wrote?
Well, you said the highest one, so it'd be the 5th degree.
So it'd be to the 5th degree. That's all they're trying to say to you.
So you need to look at the coefficient. So the coefficient,
You start with the exponent. You do not look at the coefficient. You start with the exponent to determine the degree.
Okay.
So if I write a question like Okay, so I'm looking at question number 23. And this is f of x is equal to 5x to the 4 minus pi x to the third plus 1/2.
Mm-hmm.
What is the degree of that polynomial?
It would be 4.
Okay. What is a to the 4 equal to?
A to the 4 is equal to 5.
What is a to the 2 equal to?
A to the 2, I don't think they have one for that.
So what is the number then if it's not there?
So, would it be 0?
It would be 0. What is the constant term equal to?
The constant is 1/2.
So you get it.
Yes, that makes sense.
I'm going to give you something that looks a little bit different now. I want to see if you can take the next step. And they expect you to do this without help. Some people can, some people can't. So that's why I'm going to show it to you. Okay, can you tell me the degree of that polynomial?
The degree of this polynomial, is this where you have to add them together?
Yes.
And it would be 6?
The degree is 6. Right. Now, do you know how to figure out how to write that polynomial? Because they want it written in standard form, and that's not written in standard form. That's written in factored form. Do you know Pascal's triangle?
No, I don't. Mm-mm.
Okay, I'm going to teach it to you.
And is it the reason why? Is it because they have the same exponent? Is that why you added?
Well, let's look in general. I'm going to ignore this 2 for right now. Okay.
Okay.
So if I have negative 3x to the third times x to the third, when I multiply those together, what do you get?
You're gonna get negative 3 x to the 6th power.
And that's why that's the degree, because that's going to be your leading coefficient. That's going to be your leading term when we're all done with this. So let me try to explain Pascal's triangle to you. It looks like this. There's a 1 there, there's a 1 there, there's a 2 there, there's a 1. There's a 1 there. You put these two numbers together, and you get 3. You put these two numbers together, and you get 3. And then there's a 1 there. So these are the coefficients of the terms. So if I were to have, let's say I were to have x plus 1, then the leading coefficient of the x is what?
1.
1. So that's where that number comes from. So this one would be x plus 1 squared. So if I actually work this out, I get x squared plus 2x plus 1.
Okay.
See how this number matches that one? And that number matches that one?
Mm-hmm.
So these numbers are the leading coefficients when you have a perfect square. So if I were to have x plus 1 cubed, right? Then what I do is I'm going to write it out quickly because these are all the leading coefficients. So this would be x cubed plus 3x squared plus 3x plus 1. Do you see how these numbers here match the coefficients in the polynomial?
Yeah.
Okay, so if I'm going to build another layer of the
It's basically
triangle,
telling you what your coefficients are.
they're telling you what your coefficients are. Now we're going to have to do one extra step if this number is not 1, but I'll show you how to do that in a second. Okay. So the next layer of the triangle is going to look like this. There's a 1 here. You take those two numbers and add them together. What do you get?
4.
You take these two numbers and add them together. What do you get?
6.
You You take these two numbers, add them together, what do you get?
4.
And then there's always a 1 at the end. So can you write the polynomial for the fourth power? I want to see if you can follow the pattern.
Okay. Always a 1 at the end. Okay. Okay. Let me write it.
All right, tell me what you got.
Okay. I have x to the fourth power plus 4, x to the third power plus 6x squared plus 1.
You missed one.
Oh, plus 1.
Plus 4x plus 1.
Oh, okay.
Do you see what I
Yeah, because
circled
1
before?
is okay. Plus 4x plus 1. Okay. And so this goes in order of the degrees?
Yes, this goes in order of the degrees. This would be the first degree.
Mm-hmm.
This is the second degree. This is the third. And then this is the fourth. And if you have a degree higher than that, then you do the exact same pattern to build the next layer. So you always start off with a 1, and then you add the two together, and then it gives you the next number. That's called Pascal's triangle. Do you have a question, or are you ready for me to do the next step?
Does that go with only x plus 1, or you can use that with several different kinds?
That's the next thing. I'm going to show you how to do the next layer, but I want to make sure that you understand where the coefficients come from before I do the next layer. Because you can do that with anything that's a parentheses and a power. That's what I'm going to do next. But I want to show that to you before we do it.
Okay.
So are you straight on that? Do you see how the pattern works?
Yes. It always starts with 1, and then you add that 1 to find what the next coefficient will be.
Right.
And then it always ends with 1.
And then it always ends with 1.
Okay. Yeah, I'm ready.
You ready? Okay. So now I'm going to go back to doing the question that we started off with. Because that one has a 2, not a 1, right?
Yeah, it does.
I'm going to do this in 2 steps. First of all, I'm trying to do x plus 2 cubed, right? And so I'm going to set it up by writing in my coefficients first. So my coefficients were 1, 3, 3, 1. Was that the same layer of the triangle? Did you write the triangle down, by the way?
I did.
Okay. Do I have my coefficients right?
Okay, so you want me to check the coefficients?
Yeah, I want to make sure that the coefficients are right so I know that I'm doing the question right. Are those the proper coefficients for that degree?
Okay, let me check. 1. Yes. For the third degree.
For the third degree. Okay, so now I'm going to write in my letters. Okay, so it always starts off with the highest degree. So this is x cubed. The next degree down is x squared. Then this is x to the 1, and then this one would be x to the 0. So it goes down in number for the letters as I move from left to right. Okay? You following me what I just did there? Now, when I have a number that's not 1, and I'm going to put them in red, then it goes down for the exponents moving that direction. So this starts off with 2 to the 3. This one is 2 to, sorry, I shouldn't do that. This one is 2 squared. This one is 2 to the 1, and then this one is 2 to the 0. Do you see what I'm doing?
You said if it doesn't start off with 1. So was it the x that started off with 1?
Look at the x. Look, okay. This is what I want you to do. Look
right
at
here?
the exponent. Look at the exponent as you go from left to right. What's happening to the power as you move from left to right for the letter? The ones that are in black. The ones that are in black. The letter, not the number. Ignore the coefficients and just look at the exponents.
Well, the exponents are decreasing.
Okay. For the number, this 2, as I move from right to left, the numbers decrease. Do you see that?
Yeah, it's still decreasing.
So it decreases one direction and increases in the other direction. Do you see that? So now if I want to know what this actual polynomial is going to be, now I do the math. What is 2 to the 0?
It's 1.
What's 1 times 1?
1.
So this is going to be, and I'll put it in blue. So my answer for that first term is going to be just x cubed plus, what is 2 to the 1 equal to?
2 to the 1 is equal to 2.
What's 2 times 3?
2 times 3 is 6.
So this is 6x squared. Do you see what I'm doing now?
Yeah.
Okay, do the next term for me then.
The next one is 2 to the 2, which is 4. And so 4 times 3 is 12. So 12x.
Do the last term.
And then 2 to the 3. 2 times 2 is 4. 4 times 2 is 8. And then 8 times 1. So 8.
So that's how you build the polynomial using Pascal's triangle. So now, if I actually want to write my g of x, then I have to take negative 3x cubed times the polynomial that I just wrote. So distribute that for me.
Okay. Negative 3x to the 6th power plus minus 18x to the 5th power minus 36
Good.
x to the 4th power.
Yep.
Minus 24x to the 3rd power.
And so that's your polynomial in standard form. That's what g of x, that's what they would want you to write for the actual answer to the question.
Wow.
I know there's a lot of stuff. We should probably practice it so you can do it.
Okay.
But when you're attacking the problem, the first thing you do, so step one is you write the coefficients.
Okay.
I'm just going to abbreviate it that way. Step two, you write the variables in descending order. So going down. Let's write going down. From left to right. Step three, whatever this term is, whatever that number is, you write the powers going down from right to left.
Okay.
And then step four is you multiply. To simplify it. So those are the 4 steps when you're actually doing a polynomial that way. So I'm going to give you another one to do because I want to make sure that you understand how to do it. And I'm not going to help this time. If you get stuck, then I'll help you. But I want to make sure you know how to use Pascal's triangle. All right?
Okay.
Obviously, you have all of this. Did you write down the steps, by the way?
Yes, I'm writing it right now.
Okay, let me know when you're done. And then I'll erase it and give you one to try.
Okay, I'm done.
First question, is that a polynomial?
Yes.
And what degree is that polynomial?
2 plus 4, so 6 degree.
Mm-hmm. And now I want you to write it in standard form. And you might need a calculator, by the way. Actually, I'm going to make this easier. Hold on one second. I'm going to make that number smaller. Because now you don't need a calculator to do that math.
Okay. Well, the first thing you want to do is write the coefficients.
Okay, so tell me what the coefficients are. I'll dictate for you.
Well, you have to start with the highest one, right?
Uh-huh.
Which is 4. So I'm writing the triangle.
Okay. Oh, by the way, My 10 o'clock appointment is probably only going to last 30 minutes. Is it okay if I call you or text you when I'm done?
Um,
Will
the
you?
the only thing is I have orientation at 11 o'clock my time, so I don't know about the next hour. I'm just not sure.
Okay.
I have to get ready to go.
Okay. Well, when I'm done with him, because that'll be like 9:30 your time when I'm done with him.
Hmm.
So I was saying 11 o'clock or 10 o'clock my time. It's only going to take me about 30 minutes because I'm just setting him up online, and then we're not actually doing any work.
Yeah, so maybe I'll have 30 minutes to tutor, and then the other 30 minutes can be another time.
Yeah, that's fine. But if you're running short on time, then we can just postpone it. Do you have any time before your test on Thursday to see me?
I believe I will. I'm just trying to see what I need help with right now.
Okay, I'm sorry. Sorry, I'm jumping the gun. All right, never mind. I just wanted to let you know that I'm free. That's all.
Okay.
You're
Like
going to
I
see me now. No, stop.
4, it's 3. And then you have to go backwards, right?
Mm-hmm. Oh, girl, you trying to do the whole thing on your side before you give me an answer? Maybe I need to work it out over here then. Hold on. I'll get my whiteboard out.
I guess because I'm just not too fast with this. That's why I don't use it too much. But let me put some answers down.
All right. So we're going to do x4 plus.
Plus 4x plus 1.
This is x to the 4 plus 12x cubed plus 54x squared plus 8x. Are you waiting on me or are you still doing math on your side?
I'm still doing math here.
Okay. You did the first part correctly, by the way.
Okay. Almost done.
Okay.
That's 4.
I'm not going to make you write it up because I have the answer here. You can just read it to me once you have it all the way finished, and I'll tell you whether it's right or not.
Okay. Okay, I got x to the 4th power plus 12x to the 3rd power plus 54x to the 2nd power plus 108x plus 81.
That is correct.
Okay.
So the last thing you have to do is just multiply the 4x squared through, and I know you know how to do that, so I don't want to waste time doing it.
Oh yeah, you got to multiply the 4x through. Okay.
So I'm not going to make you do that because we got to move on to other stuff.
Okay. Yeah, can we move on to question 49 through 60, those kind of questions? Because that's where the graph and trying to figure out how to graph it and all that kind of stuff.
Okay. Is that on the second page that you sent me?
Oh, no, it's the same page.
Oh, the same page.
It's, let's see here. What number?
49 through 60. Okay. So it says list each real zero and its multiplicity. Determine whether the graph crosses or touches the x-axis and the x-intercepts. Determine the maximum number of turning points and determine the end behaviors. Okay, so I'm going to give you a general overview on stuff, and then we'll do some individual questions. Okay?
Okay.
So I'm just going to draw up a random... I tried to use my dry erase marker to mark on my digital board anyway. Sorry.
Everyone in my class, they had a question on question number 49. That was the one that everyone had a question on.
Okay. I'll use that one as an example after I go over the general stuff.
Okay.
Okay. So let's say that that's my polynomial. And I should be able to look at that polynomial and determine what the degree is. So this is how you do that. Every place where it crosses the x-axis is a 0. So it's got a 0 there, it's got a 0 there, and it's got a 0 there. Okay?
Mm-hmm.
So if I were to list them out, let's say that this is 9. Let's say that that's 1, -1. And let's say that that is, I don't know, -4. So those are all of my x's. So you would write the set of x's such that x is equal to -4, -1, -9. That's another way of writing the zeros. Okay?
Okay.
So if I want to write them as polynomials, then I could say that, let's say this function is f of x. So the function would be x plus 4, x minus 1, and x plus 1 and x minus, let me erase this, x minus 9. Do you see what happened to the zeros when I put it in binomial form? when I put it in parentheses? What happened to each one of the numbers?
Well, when you put it in parentheses, it's opposite, but that's actually what your x would be when you equaled it to 0.
Right, right. So what is the degree of this polynomial? Can you tell me that?
What is the degree?
Yes.
I believe you have to add them all together. So is it 3?
The degree is 3. How many times did it cross the x-axis?
1, 2, 3. 3 times.
Do you see how those two things are exactly the same number?
Yes.
Okay. Now we're going to deal with the turning points. So I'm going to put that in a different color. Probably shouldn't make it green. So let me make it brown.
3 times.
This is a turning point, and that's a turning point. How many turning points does it have?
When it does that curve, we consider that the turning point?
You see the 2 dots that I put there?
Yeah.
Those are called turning points.
Okay.
So how many turning points does it have?
2 times.
So what did you notice about the number of turning points in comparison to the degree?
It's less than.
How many less than?
1 less.
That's always the case.
Turning points. 2. So the turning points will always be 1 less than the degree?
Right.
Okay.
Or should I say the maximum number of turning points will always be 1 less than the degree? I probably should say that specifically.
Okay.
You ready for the next part?
I am.
Okay, so I want you to repeat to me what the degree was. What was the degree?
It was 3.
What kind of number is 3? Odd or even?
3 is odd.
Do you see the blue arrows that I put at the ends of the polynomial?
Yes.
What do you notice about the direction of each one of those arrows?
Well, they're going in opposite directions.
That's the whole point. So whenever the degree is odd, the end behaviors go in opposite directions. So if you remember, this degree was 3, right? It's the third degree. And if I look at the endpoints, they always point opposite directions.
Yes.
If I draw another little graph over here, hold on. It won't let me grab it. Okay. What do you notice about the endpoints in that picture?
They're both pointing up.
So that means that the degree is even here. You see how this bottoms out here and that bottoms out there? So it doesn't actually cross the axis, but it touches the axis. Do you see that?
Yes.
Whenever you have a turning point on the axis, it means that you have some kind of multiplicity there. So let's look at the number of turning points. Okay? So I've got 1 turning point there. I've got one turning point there, and I've got one turning point there. And I know that so what's the degree for that polynomial? Sorry, how many turning points there are?
3.
So what is the smallest degree for that polynomial?
It's gonna be 4.
4. But because where these blue arrows are, because that touches the axis,
Mm-hmm.
you have to put a 2 there and you have to put a 2 there. So the number of turning points is 3, but the degree is going to be 6. Because what's 2 plus 2 plus 1?
2 plus 2 plus 1. Well, 2 plus 2 is 4. 4 plus 1 is 5.
So even though there's 3 turning points there, in order to find the degree, you have to give multiplicity to the ones that touch the axis. So you get a maximum number of 5, so the degree in this polynomial would be 6.
Okay, so you have to give multiplicity to the turning points that touch that x-axis?
Yes. Although there are only 3 turning points, but the multiplicity is going to be the polynomial degree will be 6. Do you understand how I did that?
I'm getting there. Is it always called maximum turning points, or do we just call turning points?
You just call them turning points. It's where they turn. It's where it's where you have either a minimum value, because that's a minimum, right? Or a maximum. Do you see how that's a minimum value where I drew the arrow? So the ones that are on the
So
axis are minimum.
you don't want to say maximum because it could be minimum too. Okay. Where you have maximum and or minimum.
Right.
Okay. So you have to give multiplicity to the turning points that touch that axis. Because at first I was saying there was 3, right? So
Right.
you said that each of those that touch the x-axis, that changes to each of those doubling, like they're 2.
That's
so now
remember.
2.
Okay, I don't want you to. Okay, I'm trying to be clear. That has 3 turning points, right?
Yes.
But in order to figure out the degree, that's when you have to put in the multiplicity.
Okay. So let me write that down. So this graph has 3 turning points.
Right.
But because the turning points that touch the turning points, some turning points touch the x-axis, it has to be given multiplicity to find the degree.
Right. Perfect. That's a perfect way of saying it. Yes. Yes.
To find the degree. So if they asked you how many turning points, I'd say 3, but then if I want to find the degree, I just have to consider the multiplicity.
Right. And multiplicity is shown by this. Right? So that means that.
So each time they touch the x-axis, I should just put 2 there?
Because you're trying to find the smallest degree, that's probably what they're going to ask you. Because you don't know what it is unless they actually give you the equation. But when you add all of the degrees up, remember, we still have to get an even value because both of these are pointed up. They're pointed the same direction.
Okay.
So by the time
my question is, how do you find the degree from the multiplicity again? It makes sense, like the concept, but like adding it together, like what are you adding exactly?
You're adding up the turning points.
So the two. So that's why the degree is. You said it was 6 degree.
Right. Because what do you know about the turning points and the degree? That's the first thing that I taught you.
Because you said it was the turning points is 1 less than the degree.
Right. So if I assign even values for all the turning points that are on the axis, then I got a number of 5, right?
Okay, I think I understand what you're saying. So the turning points is 1 less than the degree, and so with multiplicity, considering the turning points that touch that axis, its turning point is 5. So the degree has to be 6. Is that what it is?
Right. Right.
With
Because it always has to be one more. Okay, and so if that's the case, then let's do the one that everybody had a question about, right?
okay, the turning points.
Just always remember that the actual degree is always one more than the turning points.
Okay.
Can I erase this?
Yes.
I'm going to write up the questions that they have there. So f of x is equal to 3 times x minus 7. And then this is x plus 3 squared. The thing that I have underlined in blue has a multiplicity of what?
What has a multiplicity of, well, I know it's going to be minus 3.
Okay, nope. Okay, so I want to make this clear to you. You see, the thing that I have underlined, the exponent is 2, right? Do you see that? Andrew, you still there?
Huh? I'm sorry. I'm writing down something.
Okay.
Okay, the new. Okay. So, okay, I'm here now. You're asking what is the multiplicity?
You see how there's a 2 there?
So the exponent is the multiplicity.
The exponent is the multiplicity. So that first or that last term has a multiplicity of 2. This one doesn't have any multiplicity because it's 1. You see that, right?
Multiplicity of 2 doesn't. Excuse me, sneezing. Okay. This one doesn't have a multiplicity because it's 1. I mean, because it's not being doubled or anything.
Right, right. So what is the degree for that polynomial?
You got to add it together. 1 plus 2 is 3.
So that's the third degree, right? So if I'm looking at this leading coefficient is positive, right? So I know that on the negative side of this thing, it has to point down. And on the positive side of this thing, it has to point up. Because if it's the third degree, what do I know about the endpoints of the function?
Well, if it's the third degree, you know it's odd, so they're going to be in opposite directions.
You see how I put those arrows in opposite directions?
Yes.
Okay, so now I'm going to put in a couple of dots. This is positive 3, so I have a dot at negative
Negative
3.
3. Mm-hmm.
This is negative 7, so I have a dot at 7.
Positive 7.
I know that the multiplicity of this is 2, so it just barely touches the axis and then comes back down.
Okay.
And this has a multiplicity of 1, so that means that it goes through the axis.
Okay, I have a question.
Yes.
Now that you said it's third degree, how did you know that the arrows are going to be pointing? I know there's one going to be up and one's going to be down, but how did you choose which way to start?
Because if I know my parent functions,
That's what I was
x
thinking.
to the third looks like this.
Okay. I was thinking that's what it was. Okay.
So I'm
So
just gonna use the shape of my parent function. If this was negative, right, then it has to look like that. It's in opposite directions.
Right.
Okay, I gotta go because I got another appointment at 10 o'clock.
Okay.
I'll post the video up. If you have some time, I'll text you when I'm done with him, and if you have some time, then we can work a little bit on this a little bit later on, or not, or then I'll just see you in the next day or two before you actually take your test to help you.
Okay. So 9:30 maybe?
Yeah, I'll text you
Okay.
around 9:30. It shouldn't be any more than that.
Thank you.
You're welcome.